specialized in building scalable and efficient software solutions. Now, my other teammates will introduce themselves.
So, hi guys, my name is Jay Upadhyay. I am a software engineer with a background in building scalable systems in fintech, software service, and health industries. So, nice to meet you.
Good evening, everyone. I am Nirav Savani. I have good skills in web development with JavaScript and React.js. Now we are going to explain the problem statement of our project, and my fellow teammate, Sandeep Singh, will start that.
So now let's go to the problem statement. So the main objective of this project is to modify the edge server operations to communicate using byte array instead of the string. Right now, the edge server's operations rely on string for communication, but the aim here is to refactor the code to use the byte array. And here, the role of edge server is to handle specific Atsign lookups and provide second tier of protocol architecture. And the main function of the edge server is to provide lookup services for a particular Atsign, which means that it handles data related to only one Atsign and ensures that there is no mixing of data between multiple Atsigns. Which is unlike the web servers that provide services to multiple websites at a time. And to solve this, the above problem statement, we found a solution which my friend Jav is going to explain to you guys. Thank you.
So, as the problem statement was explained by my teammate Sandeep, to create the solution, we came a long way. So this is the path to solution. So first of all, we started with the starter kit provided by the Atsign. First we set up the environment, then we clone the Edge Java repository from the GitHub, and we finally get an Atsign. So the main part for doing this project was to understand how the Edge server is working and how the code is working. So to test that, we first have tested all the get and put methods for the three different keys, that is shared, private, and public. Like the Edge server is working on three different keys, which I have mentioned. So after understanding the code, we have implemented these methods which were asked us to implement, and I have shared a screenshot which was like asked us to implement. Like so this is the implementation demo video, but I would like to show you the live implementation right now. So just give me a second and I'll just share my screen, my VS Code screen. Can you guys see my screen?
Yeah, we can see your VS Code.
Okay, thank you. So basically, the picture which I have showed, that methods we were asked. So this is the put method for the public key, which is using the byte array. Initially it was using the string, but we want to refactor it in the byte array. So like this is for the public key. This is for self key. And this is for the shared key. This also is for the put method for the different keys. Additionally, we have also implemented the get binary with the get request option because it was necessary as we put a null parameter in that. And this is the get binary for the public key method. This one's for the self key, and this one for the shared key. So like all the methods which were asked, we have implemented, but let's test them out. So for to test, we have created a temporary test file in which first we need an Atsign. This is my Atsign, which I have got from the start, like from running the starter pack. So to test this all different key, we have to create a different key. So this is the public key, this is the self key, and this is the shared key we have created. Now to test the byte array, we have to create a test token. I have created test token byte, and we'll send this token by put method. And you can see in the parameter that this is the using like byte array value. Similar for all the three keys. So now I'll just run this and see if this thing is working or not. So yes, by running this, we are sending the data and we are receiving the data with successful encryption and everything. So we can see that the response from the public key is here, and we get the public key and everything with encryption. Similarly for the self key, and similarly for the shared key at the bottom. So yes, the thing which we were asked to implement is working fine. And now I'll go back to slide. Just give me a minute. So yes. So yes. So now the problems. So yes, we faced problems. So first was the problem by issuing an @sign. So initially we encountered a problem like to get a free @sign, but uh, yes, our team was able to figure it out. It was a minor bug in the code, and by discussing with the Jeremy, thank you Jeremy for leading us this way, and we have fixed that. I have shared a screenshot that it will be on the GitHub. And after that, we also figure out an issue to test this key, which I have showed you. But with the guidance of Jeremy and Tyler too, we figured out how to test these keys. And yes, we have successfully completed this project. So now this learning outcome will be explained by my friend Neerav. Thank you.
As we have seen that in demo, we are using get and put method for encryption technique. So we learned how data is passed and encrypted. So during an implementation, first we analyzed how Atsign server is developed and understood the server's functionality. So which functionalities are available in the code. So we figure it out. Basically, there are three types of keys provided by the servers: public key, self key, and shared key. The Jai worked on public key, Sandeep worked on self key, and shared key was handled by me. While we were working on that project, we learned new technology which provides privacy to users' data and also give us easy way to create new end-to-end encrypted apps. So at the end, I would say that it was a good experience to work on that project. So thank you for giving us that kind of opportunity by Atsign, and thank you, Jeremy and Taylor.
Awesome. Amazing work, you guys. Really well done. And I actually see Gary in here. Gary, did you have a comment on this? Because I think you got to see some of their work as well on the GitHub.
Yeah, great work. Great work, team. It's really good stuff.
Thank you so much.
Thank you.
Thank you.
And Jeremy too. Any comments?
Yeah, same as Gary. Great work. I actually forgot you kind of fixed our register CLI, so thank you for that.
Oh yeah. Thank you so much
Yeah,
for the
yeah.
guidance you have provided. Yeah.
Yeah, it's really well done. Great job, you guys.
Thank you.
Do we have any questions, by the way? All right. Well, very well done.
Oh, I think Colin has a question.
Oh, Colin?
Yeah, I was just going to say thanks for the PR. Love PRs. Great work. But what I always remember is the pull request. So love it. Just love it when you guys spot something and are kind enough to create a pull request. So great work and thanks for that.
Thank you so much for the kind words. Thank you.
Right, cool. So group 5B, are you guys here?
Oh, yes, Jeremy, we are. I'll
Right.
just start.
You have the floor.
So, can you see my screen?
Yep, we can see Canva.
Yeah. Yeah.
Good evening, everyone. We are
It is the one అయింది బతికిచ్చింది.
Good evening, everyone. So we are from Group 5B. We are here to give a demonstration on the project MicroPython RSA Encrypt Decrypt 2048. My teammates, myself is Chandramouli, and my teammates are.
Hi, I'm Hemant Sai, and I'm good at C, Python, Java, and cloud computing and AWS.
Hi everyone, I'm Samay Jain. So I'm good at programming languages, C, C++, and Java. So like I'm also good at front end, like good at HTML, CSS, JavaScript, and SQL database as well. Yeah.
So, we were given two tasks. So the first task was setting up the PicoW and running the existing code. So the code was already made by engineers at Atsign. We had to write the test suits for any of the files present in the GitHub repository. So we chose two files, which is aes.py and main.py. So the test case should, it should have been written. I mean, it should make others understand and they can replicate it in any other languages. And here we used two modules. The first one is unit test and the second one is network. And the tools we used is, are FileZilla, VS Code, Tony, and Atmosphere Pro.
So coming to the use case, so there are mainly two use cases here. So first is that like it is like the code that we have written, like it is used to test the encryption decryption that has been written, encryption decryption code that has been written by the Atsign engineers. And it also like the second one is that it helps in testing the functionality of the code and like in order to reduce the errors. Yeah. So coming on to the demo, so I'll be like showing the demo. So I'll just stop presenting the PPT and then I'll go to the main part. So okay, just give me a minute. So right now I've just connected the PicoW hardware, and here are the files that we have loaded on the left corner to the PicoW board. So yeah, let me just like the first part, according to what my friend said, like we have to run the code on PicoW. So we are doing it right now. So here the key is being generated. So yeah. So it's showing like successfully showing the Wi-Fi is being connected. Okay, it takes a minute of time. Yeah, it sometimes takes a minute. Okay, I'll just rerun it. Okay. So yeah, in order to find the secondary for the Atsign key, it takes a minute. So yeah, the thing is we wrote a test suit using Magic Mock. So like after a long like duration, we figured out like magic mock doesn't work for a MicroPython, and like we had to optimize the code, and we had to rewrite the test cases again. Yeah, and it was successfully done. And yeah, so here, yeah, running the main code is success, and we have generated the key here. So yeah, let's go to the, okay, so each time I have to open this, I don't know. Yeah, now we shall run the main test case that we have written. Okay. We initially started in VS Code, but then due to high computational power, so VS Code, like we couldn't run from using VS Code. So we apparently shifted to Thorny though. So now like the main test cases, like all the 4 test cases passed, and we are going to test the AES.py, AES test.py. Yeah, all the 5 test cases are like passed in this as well. Yeah. Yeah.
So coming to the lessons learned, we learned the technical aspects such as importance of secure data transmission. We learned the importance of using strong encryption methods like RSA to protect sensitive data during transmission, and we used we understood how to work with Raspberry Pi and PicoW environment. We used the Raspberry Pi because it can be used to control and receive input from a variety of electronic devices, and we used Python and MicroPython. Python is used to run on large devices, and MicroPython it's used to run on small devices such as Raspberry Pi, PicoW, and codes. We have added the comments to every line which we wrote the program, like what we understood in that program, and we use style casing too. Style casing, it's nothing but the most common way to combine words into a single string, and we collaborate to work in parallel using GitHub. And the soft skills we have gained is communicating clearly and openly while exchanging ideas with my teammates and all. And yeah, the last but not least, decision making in all phases of the project. Thank you. And,
Yeah, we especially like have to thank Jeremy Taylor and Professor Kenneth Fletcher for helping us. I mean, providing us support throughout the project phase. So yeah, thank you.
All right. Awesome. I know you guys went through a lot of pain as well, so good job on pushing through it and persevering through it. Any comments from Jared?
No comments from me. Good work.
Yeah, very well done. Thank you.
Thank you.
Thank you.
Any more questions? All right, awesome job, you guys. Really good stuff. Do you have all of this code pushed to the repo or to like a new branch?
Yeah, we have just pushed everything into the repo, and then like you are one of the collaborators for my like GitHub repo.
That's right. I remember you sending me that actually.
Yeah.
you.
So you could just get all the code from there. Like if you have any.
Is it publicly available as well, or is it just me?
Oh no, it's not publicly available though.
Are you guys comfortable with
you
making it?
want? Yeah, sure. I'll just make it public. Yeah, I'll just invite. Thank you.
All right, awesome. Good stuff.
Thank you. Thank you.
Thank you. Thank you.
Okay, group 3B. You are up.
Hope you are able to see the screen. So, hi everyone, welcome to the presentation by the group 3B. We have worked on Java interoperability unit test. So this is me, I'm Sumuk. I specialize in machine learning and full stack development and over to Prithvi.
Hi all, my name is Prithvi and I specialize in the domain of cloud computing and web development. So this is saying that discovering the unexpected is more important than confirming the known. And hence, we feel like, testing is an integral part in any software development process. In this case, we would be doing the Java interoperability unit test between two clients, which is nothing but a Java client and a Dart client. So our project focuses on sending an retrieval of keys, as in sending a key from the Dart client to the secondary server and vice versa, and also retrieving the keys from the Java server and vice versa. So moving on to the solution. So basically, our approach is nothing but a seamless approach by implementing an automated test script that would run the test cases, such as testing for whether the keys have been put onto the secondary server, or if the keys have been properly retrieved by another client, that is between the Java and the Dart client. So, and also, moving on to the code. So I will be talking about the setting and getting of keys with respect to the Dart side of it. So I would like to explain the code as follows. So in this case, we will be putting the key value pair onto the secondary server. So what we're doing here is nothing but setting the or getting the directory path. What we mean by getting the directory path is nothing but choosing which platform the code runs on. It can be any platform. And moving on, so here we're creating a new Atsign, which is nothing but 59 arbiters, and setting its preferences, which is nothing but the path of the Atsign. And later on, what we're doing here is nothing but onboarding the client and authenticating the client. And moving on, we're not sure whether the client is present or not. So we're just checking if the client is null, as in if the client is present or not. And and then moving on to the implementation of ASCII. So we have set a key called rabbit, which is nothing but a string, and Atsign, which is nothing but the shared byte. So your shared byte can be either Dart or the Java client. And moving on to the namespace, which is nothing but also a string variable, and we set it as lemon. And then the next line of code is nothing but checking if we have correctly put the keys into the server or not. So that's why we have passed it as Boolean value and given it to a variable called success. So here the key is nothing but the key that we're given before, and the value is like valid. And also we are just printing out the Boolean value. It can be true or false. So it would give true if it has successfully placed the key onto the server, and it will give false if it's not being placed onto the server. And we're just giving a time delay of 20 seconds so as to give it some time to push it onto the server, and we are performing the test and checking for whether the value is true or not. Okay, next I would be moving on to the second part of the key, which is nothing but putting the key onto the server, and then So in this case, I'm sorry, getting the key from the server, which is nothing but the secondary server, nothing but the add directory. So similarly, we will be getting the directory path, as I mentioned before, nothing but any platform, and we are initializing to clients, which is nothing but the Dart client and the Java client, which in this case would be 59 albatross, that is the Dart client, and the experiment 7 is the Java client. And we have also mentioned namespace, which is again lemon. And so onboarding to the onboarding system is nothing but setting up its respect respective path. So here we are setting the path for the dark client since we are getting the keys from the Java client and it is being received by the dark client. And similarly, we would be onboarding the client and authenticating the client. And similarly, we have also implemented the ACI and we given the key as a variable called dog and namespace. So namespace nothing but the namespace you mentioned over here. And shared by is nothing but Java. So here, what we mean by shared by is nothing but when the Java client is pushing the key value pair onto the server, and shared with is nothing but the client that is receiving the key value pair. Yeah. And so here, what you're doing is nothing but we are checking if the key value pair, the retrieval is a success or not by using the applying.get method and we're passing in the active value that we have mentioned there. And so as to check for all the functionality, we're just printing success and expecting the value to be true. So your success would be true if here the value of success would be like bonus because we would be sending the value from the Java client to the dark client and we would expect it to be the same. And moving on, and I will be passing it to my teammate.
So yeah, that was the Dart part of the side, and now let's see how the Java is working. So it's nothing but sending it from Java to the directory, the server, and getting it back in the Dart and vice versa. So let's see the getting, let's see the sending part. So in the sending part, it's pretty simple. It's we're just getting the two Atsigns over here, that's equivalent 7 and 51 albatross. Once the objects are created, we are then going to create the add client manager with that add client dot with remote secondary. All the variables are initialized, and once that is done, we get our add client manager. Once that is done, we then build the key, basically the self key, shared key in this case. And once that is done, we are setting the namespace and we are just sending in the data. This is the sending part, and here we are seeing the get part. So in the getting part, here all the variables are set, like what are the parts and all. And now here the key name. The key name is rabbit, and according to it, it's the value. Yeah, so the value we are sending is like carrot, and we are expecting that to be the response. So this is where this test case comes into place when we are sending a value from Dart and receiving it from Java. So accordingly, the add client has been initiated, and we get the add client manager. And once that is done, we also get our self key. And once that's done, we are setting the namespace, and we are getting the response. And we are just asserting if it's the one we sent it. So the main part of our project is where we are making all this manual testing seamless through a shell script. So this is our shell script. So this is a shell script, and this is the shell script which is from Java to Dart. And as you can see, we're just running the test cases through shell script. It's pretty simple, and once that's done, let's go ahead and execute it. So here the Java part of the code is running. So it's executed the Java part of the code, and now it's executing. Now it's executed the Dart part as well. So here we have received like bones. That is what the key. That is what the value was, and then the test case is passed. And let's here run start the Java part. So here Dart sending the value. So it says right. Right success is true, and it is giving us the service, server commit ID. Once that is done, we are given implicit wait for like 20 seconds so that the commit will be done. So once that is done, so once that is done, the Java part is running, and the test is passed. So this is this is what our project is. This is where we test, if the interoperability is working successfully or not. So once Yeah. We experienced problems going through the development process. So we had conducted journey about like once we were sending Java, no, we were sending the key value pair from Java, but we weren't able to receive it from that. This was because the namespace wasn't set, and we got to know what is the importance of namespace and how it is used. Once that was done, we also faced issues where the Java to Dart was working, but Dart to Java was not working. And throughout the process, we had few problems, but yeah, finally rectified it. So we learned a lot of things in this. So we learned how the interaction actually happens between two clients and dived deep into Java SDK and Dart SDK and got to see how a real SDK would be and got to learn it. And we also got to know how optimization works with SDK as it is at client. And we also learned how to automate the shell script. Yeah. And if anyone has questions, if anyone has any questions, I am happy to answer it. Yeah. Thank you for your valuable time. I'd like to thank Professor Ken Fletcher. I'd also like to thank Tyler and the journey for the immense time they put in the himself in running the whole project. Thank you very much.
All right. Awesome job. Thank you so much. Had some pretty good test cases there. Thank you for doing that. I know that interoperability is a pretty tough nut to crack there, so thank you for tackling that. Jeremy, did you have any comments for that one?
Yeah, I like how you put them into shell scripts. I thought that was cool. And it's good to see that the Java client is talking well with the Dart client. So it just kind of confirms that our mode of encryptions and our key naming and whatnot is correct. Are you going to consider making a PR of this work to our repos at all?
Oh yeah, I can make it.
Cool. Thank you, Samak and Prithvi. Great work.
All right. Up next, we have 5A. Last but certainly not least. Five A ready?
Yeah, Professor.
All right, you have the floor.
Yeah. Hi everyone, myself Ritvik and our project is 5A, that is testing of RSA 2048 encryption and decryption in MicroPython. And this project is mainly is for protecting sensitive data during transmission using RSA, as it is one of the most strongest encryption methods. And moving on to my team. Myself, Ritvik, and I'm familiar with Python, Java, and C, and followed by Nimil.
Good evening, guys. Myself Nimil Latia, and I'm software developer with a passion for machine learning. I have a good, strong background in Python, Java, and C#.
Hello everyone, my name is Sri Charan Mohan Kumar. So my area of interest are C++, .NET, Python, and Java.
Moving on to problems, and the first one would be security in digital age. As nowadays, the digital age and security, communication, and data protection are more critical to secure and protect the data. And the next would be the limitations of symmetric key encryption. In traditional encryption methods like symmetric key encryption, we have more vulnerabilities and may not be reliable every time, as it may take more time to do manually. And the next one would be need for more secure and encryption. A more secure and reliable encryption method is needed. And the vulnerability of data in cloud and internet-based communication, as the increase of use in cloud services and internet-based communication has made data vulnerable to interception and unauthorized access, and highlighting is more needed for stronger encryption methods like RSA. Yeah, moving on to solutions. I'm handing over to Nimil.
Hi guys again. So we are gonna talk about the solutions. So the job of understanding the importance of data security is crucial. One use case that highlights this is sending insensitive information over the insecure networks, such as the internet, right? Let's talk about the scenario in which the secure transmission methods must be used to protect the confidentiality and integrity of the data. Such method in RSA encryption decryption. This algorithm ensures that only the intended recipient can access the information by encrypting it with a public key that can only be decrypted with a corresponding private key held by the recipient also. This means that even if anyone intercept with the information, they will not able to read it without a private key as usual. RSA can also be used for a digital signature, which verifies the authenticity of the data sender. This is the important for ensuring that the information has not been tampered with or altered in any way during the transmission. Overall, understanding the importance of data security and privacy, the use of encryption algorithm like RSA is essential for everyone, especially in the field where sensitive information is frequently exchanged. So now we're gonna now we're gonna now we're gonna describe about the algorithm of RSA 2048. So which is an algorithm used for communication. RSA stands for a reverse Sumerian arithmetic named after its inventors. It is a type of asymmetric encryption, which means that there are two different keys involved, a public key and a second one is a private key. The public key can be shared freely, while the private key kept secret. Let's move on to the implementation slide. So now the way RSA works is that the sender use the recipient's public key to encrypt the message, which can only be decrypted using the recipient's private key. This ensures that only the intended recipient can access the information. Yeah. And one important factor to consider we are using the RSA algorithm is the length of a key. The longer you use the key, the more difficult it is for someone to crack the encryption. Generally, a key length of at least 2048 bits is recommended for a secure communication. So overall, in a summary, RSA encryption is a powerful tool for ensuring the confidentiality of information transmitted over insecure network. By using the asymmetric encryption with two keys and choosing an appropriate key length, we can protect our data from unauthorized access. Thank you. So here we end with the RSA implementation. Now I will hand it over to the Sri Charan. Thank you.
So let us start with the demo. So first, so this is our code. So this is our main code which was given to us. So what we have done over here is I've just modified the menu bar over here. So as you see, the PicoW is connected to the Wi-Fi, and now there are two ways that we can run the test cases on this main class. So one is by running the main code, and we have added a test case from here only, from where we can directly run the test case. Like if we give the option 5, it will run the test case directly. So this is one way how we can run the test case. So as you can see, it is testing all the test cases which are there, like I'll be explaining shortly. So these are the test cases which we have written, and one more way to run the test cases directly by running this test code over here by using the run. Right? So here directly it runs the test case. So what the test cases are is like reading the code, reading the settings. So reading the keys which we are specifying to it. So, and here we are using the test cases for finding the secondary, connecting to the secondary address, like secondary, if we want to make a connection to any secondary person. So that connection is being tested over here. And if message is sent, so is the message reaching to the secondary person? So that is also tested over in this test cases. And one more test cases was on the encryption decryption part, which is present over here. That test case was on pkcs1.py. So first let me run this test case. So yeah. So here, this is the first, so this will take some time. In the meanwhile, I'll be explaining what our test cases is actually doing over here. So in this first test case, we test the encryption and decryption function of the of a public key encryption algorithm. So it generates